and pleasant morning to respected teachers and examiners. Today, Team 2 is going to do a presentation about the topic shapes of molecules and ions. When we talk about shapes of molecules and ions, what is the first question that pops into your mind? It is the structural arrangement of electron pairs around the central atom.
In our presentation, we are going to discuss about the Vesper theory and shapes of molecules.
Let us head right into the introduction to shapes of molecules. In simple terms, the number of electron pairs around the central atom and the nature of these pairs are the important factors to determine the shapes of a molecule.
Moving on to Vesper theory, also known as valence shell electron pair theory, it is a model used in chemistry to predict the geometry of individual molecules from number of electron pairs surrounding their central atoms.
When we look into the shapes of molecules, they all are three-dimensional. As mentioned, there are 11 different shapes of molecules: linear, trigonal planar, tetrahedral, trigonal bipyramidal, octahedral, angular, pyramidal, T-shape, seesaw shape, square planar, square pyramidal.
Before discussing about the shapes, let us get familiar with the electron pair geometry. The distribution of bonding lone pairs around the central atom is called electron pair geometry. It depends on how repulsive units are distributed in 3D space, icosahedral, trigonal bipyramidal, and octahedral, from which we obtain the shapes of molecules and ions.
The first structure is known as linear. This can be observed when there are two electron pairs. You can see we have three atoms here. The bond angle is 180 degrees that forms a straight line.
The examples are BeCl2, CO2, HCN, NO2, XCF2.
Let us look at the two possibilities. In case 1, there are two bonds and 0 lone pairs. In such situation, the molecular geometry is linear as well as the electron geometry. Examples are HCN, NO2 plus BeCl2, CO2. Moving on to case 2, there are two bonds and 3 lone pairs. In such situation, the molecular geometry is linear, but the electron geometry is trigonal bipyramidal. Examples are I3 minus XCF2, I3 minus. Carefully observe the two figures.
Next is the trigonal planar. Here you can see three atoms surrounding the central atom at the corners, forming an equilateral triangle. All are in one single plane. The bond angle is 120 degrees. In this figure, you can see 3 bonds and 0 lone pairs. In such situations, the molecule geometry is trigonal planar, so is the electron geometry.
Excuse me, sir.
COCl2, SO3, CO3 2 minus.
100 all
The examples for following are CCl4, XeO4, and CH4.
Looking into the next structure, you can see two central atoms and 5 more atoms at the corners. The molecular geometry is called Trigonal Bipyramidal. The three atoms that shown vertically have bonds in the same plane. The bond angles are 90 degrees and 120 degrees. In such situation, the molecular geometry and the electron geometry remains constant. That is trigonal bipyramidal.
The examples included are PCl5, SbF5.
Moving on to the next molecular geometry, that is octahedral. As you can see here, we have a central atom bonded to 6 other atoms. Above and below, the bonds are in the same plane. The bond angle is 90 degrees. There are 6 bonds and 0 lone pairs. The octahedron has 8 faces. Hence, the prefix is octa. In such situation, the molecular geometry is called octahedral, and so is the electron geometry.
Here are the examples, MoCO6 and SF6.
Now let's understand the shape of the molecules in detail. The angular shape takes form when there are two bonds attached to the central atom, along with one or two lone pairs. The examples are H2O, SO2.
While analyzing the formation, there are two situations of having the angular shape for the molecule. In case 1, there are 2 bonds and 1 lone pair. Such an arrangement can be observed in SO2 molecule. In such situations, the molecule geometry is termed as bent, and the electron geometry is termed as trigonal planar. Moving on to case 2, there are 2 bonds and 2 lone pairs. Such an arrangement can be observed in H2O molecule. In such situations, the molecule geometry remains bent, but the electron geometry is tetrahedral. Now carefully observe these figures to make out the difference.
The next molecular structure is in the shape of a pyramid. Here, the central atom at the peak possesses either 3 or 4 valence bonds, forming the base of a pyramid. In this figure, there are 3 bonds and only 1 lone pair. In such situations, the molecular geometry is trigonal pyramidal, whereas the electron geometry is tetrahedral. The examples include XeO3 and NH3. As you can see, the bond angle in NH3 is 107 degrees.
Moving ahead, there is a structure that represents the letter T. The molecular geometry is labeled as T-shape. There are 3 bonds and 2 long pairs around the central atom. In such situation, the molecular geometry is T-shaped and the electron geometry is trigonal bipyramidal. The examples you can find are BRF3 and CLF3.
Looking into the next structure, you can see a central atom bonded to 4 other atoms in a seesaw shape. The name is derived from the observation that it looks like a seesaw. There are 4 bonds and only 1 lone pair. In such situation, the molecule geometry is termed as seesaw, whereas the electron geometry is again trigonal bipyramidal. The examples included are XeO2F2 and SF4.
Now, let's have a look at the situations where we have atoms positioned at the corners of a square on the same plane. There are 4 bonds and 2 lone pairs. In such situations, the molecular geometry is square planar, but the electron geometry is octahedral. The examples for the following are XeF4 and ICl4. As you can see in the figure, the above and below are the 2 lone pairs.
Moving on to the last molecular shape, that is square pyramidal, there are 5 bonds and only 1 lone pair around the central atom. In such situation, the molecular geometry is termed as square pyramidal, whereas the electron geometry is again octahedral. The examples included are BrF4, XeOF4.
Now, let us watch a self-made video that will help you to quickly memorize the shapes of molecules. And on creating this video, we should afford our special thanks to Oshada and Manuli.
Hello everyone. In today's lesson, we are going to memorize the molecular shapes. To start off, let us write out some numbers. The numbers are 21, 22, 31, 32, 41, 42. Pretty simple, right? We are also going to include 23 and 51. The numbers on the left represents the bonding pairs, whereas the numbers on the right represents the lone pairs. If we draw a line under the numbers 22, 23 and 32, we would obtain 4 separated groups. Then we can use the acronym B, L, T and S for each group respectively. B stands for bent, L stands for linear, T stands for trigonal pyramidal and T-shape, and S stands for seesaw, square planar and square pyramidal. When we look at the letter T, it stands for 2 names, trigonal pyramidal and then T-shape. The way to remember the order is by observing the first letter in the second word. As you know, P comes before S in the alphabet. Now on it gets a bit trickier. The last acronym stands for 3 names: seesaw, square planar and square pyramidal. The way to remember the order is that the P and S gets flipped here. In this case, letter S in saw comes before the letter P in planar. Now look at the second letters of the last 2 names. Here it follows the regular alphabetical order, as the letter L in planar comes before the letter Y in pyramidal. Therefore, it's seesaw, square planar and then square pyramidal. This method is meant for the molecular shapes. Now, notice the right side where the lone pairs are placed. You can see they are never zero. Structures with 0 lone pairs are found in electron pair geometry. There is an easy method to memorize that. First, write down these numbers 20, 30, 40, 50 and 60. For the first one, think about a line as in linear. You can see that it has 2 points. Therefore, 2 zeros will make it linear. Additionally, look at trigonal planar. The prefix is tri and hence it coincides with the number 3. Next is tetrahedral. It has a prefix tetra which coincides with the number 4. The trigonal bipyramidal has 2 prefixes, tri in trigonal and bi in bipyramidal. If you add up 3 and 2, you get 5. Finally, the prefix octa means 8 in octahedral. So 8 times 2 is 16, and the last number 6 coincides with the 6 on the other side. I hope this has helped you.
I sincerely appreciate your attention throughout, and that brings us to the end of our presentation. Hope everyone has benefited from it and gained the needful idea regarding the topic presented. If anyone has any questions, please feel free to ask and we'll do our own best to answer. Thank you for joining with us.
So any questions? You can ask the questions from our students.
I would like to ask what is the criteria that you are using to choose what the central atom is of a molecule? Did you hear me?
Yes, we can hear
Yes.
it. Yes, now students can answer. Who is answering? Please tell your name and answer it.
I'm Gihanga Nimbari. The central atom is chosen out of the atoms given. The central atom is the electropositive atom. That means out of, every atom has an electronegativity. So the atom with the least electronegativity is chosen as the central atom, which is the electropositive atom. Thank you.
Yes, Shavinda, is it okay?
Yes, sir. You're welcome. And I have to note them that now in the case of hydrogen, it's an exception. We don't use hydrogen as a central atom. That's all.
Okay, now please, Sarah.
Yes, sir. They said that during the presentation that XeO4 or xenon tetraoxide, they gave xenon tetrafluoride as an example for tetrahedral geometry. I want to know whether it's a stable compound or unstable one in room temperature.
Yes, anyone can answer. Yes, students, you can give your points. Just try to defend the answer. Yes, Sandanika.
As it is in the 18th block, it's a stable element.
Yeah, I'm asking whether the compound xenon tetraoxide is a stable element at room temperature, or is it stable? Or is it not stable at room temperature? No.
I am Vihangi. Xenon tetraoxide is a stable compound in room temperature because around the xenon atom there should be 8 electrons. Then oxygen is bonded to xenon with double bonds. So oxygen is obeyed to the octet rule, and also around the xenon there are 8 electrons. So xenon tetraoxide compound is a stable compound in a room temperature.
Yeah. First of all, in XeO4, there are 16 electrons around Xe, because since Xe is actually has an electron configuration which is about 3s2. But my question was whether xenon tetrafluoride is a stable or unstable compound in room temperature. According to the question, you should have just said whether it's stable. It's okay. Anyway, xenon tetrafluoride, for the record, the xenon tetrafluoride compound is unstable at room temperature. It says that it is stable below 35 degrees, or it is very explosive in temperatures above -35 degrees. Thank you.
Pinsara, because
Yes.
of that question, it's a bit out of our A-level criteria, A-level and A-level
So,
limit. So can you ask one more question in order to cover your question part, except that question?
they gave xenon tetraoxide as an example for tetrahedral geometry during their presentation. That's why I asked it. Okay, sure. I will ask you another one.
Okay, Shavin, sorry, Sachita. Sajida.
Yeah. Good morning, dear student. Thank you, Dulan sir, for inviting me as an examiner. So, our student, you all try to do a good presentation. You all can hear me, right?
Yeah, we can hear you.
Yeah. So there was some communication problem, but they are okay. Did you all practice this presentation with group members?
Yes, madam. We did rehearsals.
Oh, okay, good. I think this may be your first online presenting experience, so I can appreciate your effort. So this is my question. Your team, you all got a question. Your topic is in our lesson number 2, structure and bonding. So I would like to give a questions which we usually find in our exam paper. I will share my questions. I think you can see the screen, right?
Yes, it's visible.
Yeah. Shape of which of the following species is OR similar to that of sulfide, SO3 2 minus ion. This will take a few minutes to get the answer. So you no need to be hurry. Take your time and give me the answer.
My name is Jitme. The answer is BRO3 minus.
What is the shape?
Trigonal pyramidal.
Yeah. There's one more molecule here.
It contains more than one answer.
Yeah.
So can you point out the other one also?
CO3 2 minus.
CO3 2 minus. Can you try more?
NH3
and BRO3 minus, right? Can you give me a clear answer as
Yes,
the final
please
answer?
confirm the final answer. Please confirm the final answer by one of the team members. And if you can switch on the camera, it's better.
PRO3 minus, CO3 2 minus, NH3.
All three. Yeah. CO3 2 minus. CO3 2, yeah.
CO3 2 minus cannot be included.
Yeah. So the answer is
BRO3 minus and NH3.
okay, very good. The answer is A and B.
Yes.
Okay. Okay.
This and D. Okay, so now our question session that is over from here. Pinsar, are you willing to go to a question?
Yes,
Please keep this.
Yes, sir. Shall I share the question too, sir?
Slide on, please. Okay. Please ask.
It's a MCQ. The valence shell of the central atom of a certain species has 5 electron pairs. 3 of them are lone pairs and the rest are bond pairs. What is the most suitable geometrical shape that this species would possess? First answer, octahedral. Second answer, linear. Third answer, square planar. Fourth answer, bend. Fifth answer, tetrahedral.
Now here the question, now we can answer. The valence shell of a central atom of a certain species has 5 electron pairs. 3 of them are lone pairs and rest are bond pairs. What is the most suitable geometrical shape? Yes, Oshade?
My name is Oshada. The answer to that question is linear.
Yeah, correct. That's the.
Okay. Pinsara, is it okay?
Yeah, okay. That's good.
Okay. So that's the end of your question session. And then we'll be adding you to the waiting room. Please leave from this session. Leave means I'll be adding. Okay, let's wait. So the examiners, they have decided the marks, and we are going to reveal your final marks now. Now this is time for your performance. Examiners, you can comment on the marks of the students. I'll reveal the final marks. The final mark I'll be revealing. All the examiners, they have given 18 marks out of 25 for your overall performance, and then the average also 18. So that is 18 out of 25 for your group performance, and then that mark will be added to your school-based assignments in your A-level examination related to your A-level examination. Okay, now examiners will comment. Yes, shall we start from Sachita? Yes.
Yes. Yes, dear students, as I told you earlier, your overall performance is really good. As this is your first experience, so you all did well. So thank Dulan sir for giving this opportunity to our students. The criteria we looked into when marking, there are 5 points for accuracy of slides, teamwork, communication and organization, power of presenting and management and time management, and answering for questions, then creativity and overall quality of the team spirit. These are the 5 points we looked into when marking. According to my marking schedules, you all got 4 lower marks for answering the question. Other than that, other 4 points are okay. And here I should appreciate your short video. It's really good, and the way of presenting that video is I really appreciate. Again, I would like to wish you good luck and enhance your presenting skills. This type of presentations we did in earlier years also, but not in this way. The live presentations, we did it at your classroom. So this is a very good experience for you. This will really help you for your future future studies also. So thank you for participating. Thank you for your effort, and thank you, Dulan sir, for inviting me also.
Okay, yes. Pinsara?
Yes, actually, it was a really great presentation. I mean, there were a few mistakes here and there, but overall, it's a good presentation. Uh, accuracy of the points were quite good, except for there was only one point which you added example which is out of syllabus. Other than that, everything was perfect. And when it's come to teamwork, communication, and organization, there were bit issues. I think it was with the connection or uh, due to the lack of time uh, of practicing before the presentation start. So I gave 2 marks for teamwork, communication, and organization, but I gave 4 marks for accuracy of points and slides. So and when you are talking about the power of presentation and voice, speech, and time management, you get 4 marks from me because yeah, everyone participated during the presentation. While I mean, like so, I think all 10 members participated during the presentation. So the work divided evenly according to the members. So I gave 4 marks for that, and for Viva answers, I gave 3 marks because for this teacher's questions, you had to give like try 3 times to attempt the correct answer. And for creativity, I gave 5 out of 5 because uh, because of the presentation and the video. I mean, the video was great, like so perfect. Uh, and the presentation, I mean, presenting of the video is also great. And you did it perfectly. So I gave 5 out of 5 for that one, and it sums up overall marks as 18 out of 25. And honestly, I'm so amazed by your performance. So keep it up, and thank you for presenting, and thank you, Dulan sir, for inviting me.
Okay, Pinsara, thank you. Okay, the final chance now, Shavinya. Okay, do it.
Yes, sir. Now, first of all, as the 2 examiners mentioned, I'll agree with their points also. And I like to say that we highly appreciate your effort on this presentation. And yeah, the presentation was very creative, as we did not expect, like, because it's an online presentation and you all have never, this is your first hand chance. So we did not expect such a great performance, but it was really good. And there were some doubts in your language. Some of you have to be well concerned about your language and also the communication skills, because maybe because of this online sessions and all, there was some doubts in the communication skills between the group members. But you guys can improve it more later on when doing presentations. So my according to the criteria, I'd like to align my marks like this. Accuracy of the points and the slides, I give 4 marks because you all did a great presentation and it was really colorful and it had a lot of things to get from the presentation. And also the teamwork next, and communication and organization, I just gave 3 marks because as I mentioned before, there were some doubts in your organization and communication between team members. The next presentation skills includes voice, speech, and time management. I gave 4 marks. There were good presenters in your team, and there were some doubts, simple doubts between some students, so that can be improved. And also the Viva session, I gave 3 marks because as in madam's question, you guys had to attempt a lot to come to an answer, and you gave false answers at the beginning. So 3 marks I awarded for that. And then creativity and overall quality, I awarded 4 marks. And also I want to mention you that the last video you all did, the small video, it was really great. I would like to ask you if you could share them with all the other members of your class. And I also remember we did such a presentation in school, but it was a live performance. So this is your first, this is a new experience and it's your first chance, no? So it's really great. Thank you. And Dulan sir, thank you for inviting me.
Yeah, sure. Okay, so it is my pleasure. Okay, so dear students and all the examiners, thank you very much for joining this session. And in order to make this a success, my dear students, you have done it really well. I'm really proud of you. That's what I have to say simply. So then we are going to wrap up the session from here. This is your chance. So wishing you all the very best for your studies and everything. So examiners will be continuing to the next session. Okay, thank you. I'm going to finish the session from here. Okay.
Thank you, sir.